start the session. So, am I audible?
Hello.
I think I am audible. Okay, so we will be starting the session now. So, I will be starting with giving a brief intro of who Sir is. So, just a minute. Fix my mic. Sir is an associate professor in the Department of CSE at NIT Delhi. He has previously served as Dean of Research and Consultancy as Head of Department at NIT Delhi. His primary research interests span a diverse range of areas, including network theory, dynamics, on and off networks, epidemic modeling, synchronization, AI and machine learning, quantum networks, video catchment, and time-varying networks. With extensive teaching experience at both undergraduate and graduate levels, Sir has taught courses ranging from foundational subjects to advanced specialized topics in computer science, engineering, and mathematics. He is dedicated to mentoring students and currently guides graduates, masters, and UG students at MIT Delhi. Uh, his academic portfolio includes approximately 80 publications in leading journals and conferences, highlighting his thought leadership and extensive contribution to research. He has successfully completed two projects funded by Department of Science and Technology, one of which involved collaboration with a startup. Presently, he is working on a project supported by the Ministry of Earth Science and Technology Innovation Hub at IIT Patna. So, sir, handing over to you.
Okay, thank you for introduction. So I cannot see the participants here, or can I see? Okay, I cannot see, I think. sh- So can you see this, my shared window?
No, sir.
Now?
Yes, sir. Now you can. Now.
So first of all, thank you for inviting me for this FTP program. So now the topic of today's topic for my presentation is cloud security and privacy. So actually I divided this presentation into three categories so that you will have better understanding about this topic. So in the first part, actually I will cover the basics of cloud so that you can understand how clouds are performing, how clouds, what is cloud computing, what is the importance of cloud. So just little bit introduction. And second category, how the things will be computed over the cloud. And in the third part, we will cover about the security, cloud security perspectives. So if we will start the presentation from the start. So what is cloud computing? So cloud computing basically the two term cloud and computing. So cloud computing basically refers to the applications and services delivered over the internet. So the main cause for having all these facilities are the available internet. So you can connect to any other machine. So once you are able to connect any other machine, then definitely you can take the computation, storage, software, whatever you want from the another machine, you can take it. So software delivered over the internet is usually referred as software as service. So actually cloud computing is divided into various categories. Okay. So if we will see, first is called SaaS. So what is SaaS? Software as service. So in this case, what will happen? You will be given software as a service. It is ready to use software applications delivered over the internet. So basically no infrastructure or software maintenance required by the user. You need not to install the software, particular software over your machine, and it can be accessed through the remote site. Like nowadays, you can use MATLAB over the cloud. You can use MS Office, MS 365 over the cloud. So the major advantage is that without any creating infrastructure or software maintenance, you can use it. So I told you already the example. Gmail is the example of software as service. Microsoft 365, any Dropbox. So there are many. Salesforce.com is also. So cloud usually refers to data center infrastructure that runs those services. So public cloud is shared by multiple. So in the category of cloud, cloud is divided into two categories, public and private. So basically, public cloud infrastructure owned and operated by third-party providers like AWS, Azure, Google Cloud. And in this case, resources can be shared multiple users. So why we prefer the public clouds? Because it is more cost effective, scalable, but control is less in this case, you know. So usually public cloud is very famous because of the theory, usually pay as go, you based access. So actually, once resource are shared among the multiple people, so it will be you need to use the resource and just you have to pay whatever resource you have used, and for the time, not for all the time you have to pay. You have to pay just for this basis of uses. So example is Amazon Web Services is a public cloud. Now in the second category, private cloud is generally managed and owned by the single organization. So what is private cloud? That is the cloud infrastructure dedicated to a single organization. And it may be hosted in premises by the third party, or it actually offers more control, and definitely if it is a private, so your data is not, there's no fear of sharing of data because other clients are also sharing the resources. So that fear can be gone away from here. So it offers more control, security, and customization is also possible because single organization is there. Now third is storage as service. So in the case of storage as service, you can use the storage service from the cloud platform like Microsoft Azure, Amazon S3, like this. So what is new in cloud computing? So basically, what is computing? Basically it is equivalent to utility. So you do not build a power generator in your home. No need to hire someone to take care of your power generator. So it is like that. Suppose you need electricity in your house, so you need not to install generator at your house, because if you will install generator, then you have to spend lot of amount in the maintenance, and you have to hire one person also for that. But if somebody has centralized power generator and they are distributing the electricity and they are charging from you as per the uses of electricity, so definitely that is much more useful for you. Nowadays, same thing you can see in the example of your gas connection. So there are three new aspects are there. The illusion of infinite computing resources, no upfront cost to use public clouds, pay as you go model. So what is the cloud opportunity basically? So in terms of technology, economic and business model. So you know that there are mainframe computers initially. So they are centralized compute and storage thin clients. In economic point of view, okay. So I have to change the sharing mode, so you will get it. Okay, so I am showing you. So I started from here. I told you utility, and I am here cloud opportunity. Can you see slide now? It is moving.
No, sir, no, sir. We cannot see the screen. Sir, if you are sharing
It
like
is
share full screen.
it is not shared, or you are not seeing it. It is not moving.
No, sir, now we are not able to see your screen.
Okay, okay, just wait. This sharing option is gone. It is connecting. Just I have to refresh it. Can you see this
Yes, sir. Yes, sir. Now it is full screen.
moving now?
Uh-huh.
Okay. So, in the case of mainframe, what is the economic concern? Optimized for efficiency because of the high cost. You can imagine that for mainframe. Business model, high upfront cost of hardware and software. And then we moved in the client server architecture. So, use the technology that PCs and servers for distributed compute, storage, and so on. So, if you have large process to compute, so it can be distributed over the different machine. So it is optimized for agility because of the low cost. Perpetual license for OS and application software is the business model for that. So once we will go into the cloud technology, then large DC's ability to scale commodity hardware devices. So large are there. So the ability to scale commodity hardware devices. See, you can scale your hardware at your home without maintaining the actual infrastructure. So you can borrow it from the cloud. So economically, it leads about the efficiency and agility in order to magnitude better. So if you see the business model, so ability to pay as you go and only for what you use. So it is very good business model for the users. So what are the trends supporting cloud computing? So mobile interactive applications respond to information provided by user and sensors in real time. Rise of analytics and big data. See, once you are keep analyzing the big data means because there are many sources those are generating the data. Your mobile phone, your smartwatch, there are many sensors, even in sensors in car, e-commerce sites. So many people are there. Those are generating the data. So the main problem is that from where that data should be analyzed. So we need a big storage and big computation. So because of this, cloud is very important in this case. So parallel batch processing is used when large data will be processed. So I will cover in this presentation that part. So for parallel batch processing in the cloud computing part, Hadoop and MapReduce can be used. So it actually supports new business model, pay as you go. So we already talked about. So now the whole responsible thing for all these technologies are the arising of big data, emergence of big data. So big data can generate significant financial value across sector. So there are some example you can see health sector, public sector administration, location of data, location of your mobile data, retail stores, manufacturing. So there is big emergence of big data. So big data has now reached every sector in the global economy, like other essential factors of production such as hard assets and human capital. much of modern economic activities simply couldn't take place without it. So big data basically creates value, creating transparency, enabling experimentation of discover needs, expose variability, and improve the performance, and definitely for better future prediction. So there are you know about the big data, so I am not going into the detail of that. So cloud computing infrastructure variants computation model. So if you see the computational model, then you will take the three example, Amazon Web Services, Microsoft Azure, and Google App Engine. So they will use this architecture, and here computation elasticity allows scalability, and developer must build the machinery or third party. So if you go into the case of Microsoft Azure, then Microsoft Common Language Runtime virtual machines are there. Okay. Machines are provisioned based on the declarative descriptions. And what about Google App Engine? Predefined application structure and framework, programmer provided handlers written in Python, all persistent state stored. So automatic scaling up and down of computation storage can be done also in Google App Engine. And once we will talk about these are the computation model. Once we talk about the storage model, so Amazon Web Services range of models from block storage, okay, to augmented key blob store. Automatic scaling varies from no scaling or sharing to fully automatic depending on which model used. If you go to the Microsoft Azure, SQL data services, restricted view of SQL Server, Azure storage services are there. And Google App Engine is ready for mega store or big table over that. So this is the cloud computing infrastructure variants among various examples. So definitely there are different networking model. I am not going into the detail of networking model. So if you see the example of Microsoft Azure, so these are the various businesses, those are attracted internet, and see, businesses are interacted with the data center, and consumer are also getting the things from the data center. So what data center actually take here at the Microsoft data center, in the case of Microsoft Azure, they have Windows Azure, and they have various applications. So various applications are required to handle things. So if you wanted to know what is Windows Azure, so previously it was Windows Azure, now we call it Microsoft Azure also. So that is basically infrastructure as service and platform as service and software as service. It offers basically both three. So it provided the global network of data center which is required by this. Okay. So, and there are a lot of data residing over the data centers, and you can see the large storage space is available at that data center. So actually it leads to platform as service. So once you will talk about platform as service, it means it provides a platform with tools for developing, testing, and deploying applications. Okay. So I'm repeating again, platform as service means it is providing tools for developing, testing, and deploy applications. So various applications are there for this purpose. It provides tools for building SaaS. So what is SaaS? Software as service. So whatever tools required to build this software as service, it will provide. And these all software sits on the Microsoft data center. So this is the Microsoft Azure example. So how compute will be done? So compute runs applications in the cloud, and those applications largely see a Windows Server environment. Although the Windows Azure programming model is not exactly the same as the on-premises Windows Server model, And what is storage? It stores binary and structured data in the cloud in this case. Fabric controller basically deploys, manages, and monitors the application. And CDN, which is called Content Delivery Network. So it speed up global access to binary data in Windows Azure storage by maintaining cached copies of data around the world. So there are many cached copies can be put, so the communication will be taken care by Content Delivery Network. And we have Connect also. So what is Connect? Allows creating IP level connections between on-premises computer and Windows Azure applications. So you can see the major 5 components: compute, storage, fabric controller, content delivery network, and connect. And these are the applications and data over the Windows Azure. So this is the structure of Microsoft Azure here. So basically what Microsoft Azure Compute, if you will see compute, there are various web role instances are there, worker role instances are there, and virtual machine role instances are there. So 3 type of instances are available in the compute. If you see, compute means runs applications in the cloud, and those applications largely see a Windows Server environment. So these 3 instances will be there, and load balancer will take care. And that will be taken care by HTTP and TCP. And the red square, all are the virtual machines. So Azure Compute, it is a developer needs to submit configuration to define various roles. Each role will be assigned a virtual machine by Fabric controller. Load balancers are there, and monitoring and debugging services are provided by the Azure. So, okay. So if you go to the Microsoft Azure storage, so blobs are there. Tables, various tables are there, and queues are there. So actually blob, basically this is blob storage. So basically it is the Microsoft Azure service for storing massive amount of unstructured data in the cloud. So actually it leads, I'm checking, is there any query? No. Okay. So basically this blob is storing massive amounts of unstructured data in the cloud. And there are tables, and also you are seeing queues in the Azure. So what structure they are taking care, because all 3 are related with the storage. So basically Azure tables have a structured data in the NoSQL key value store. Actually data stored in here in the form of table, and you know the table entities are there, and each entity will be defined by some of the properties. So this is called Azure Table Storage. So once you will go to next Azure Queue Storage, so a message queue service for reliable communication will be there. Actually here each of the queue will store an ordered list of various messages, and accordingly synchronously, not synchronously, it is asynchronously. So this is the Microsoft Azure storage. So here the descriptions are there. Blobs are used to storage binary objects such as videos, images, similar to blobs in database. So containers can contain multiple blobs. Tables similar to Google Big Table entities. Each entity has properties. It will be stored. Need to use OData to query, distributed storage to scale to big data. So we will talk about how distribution will scale to big data. And queues allows the web roles of communicate with worker roles. So web roles can issue a computation request. So all the service request will be in the queue, and accordingly it will be processed. So now if we will talk about Azure Fabric Controller. So as I told you initially, what is the meaning of Azure Fabric Controller? So this is the structure basically. So I already told you Fabric Controller is like the Actually, controller means it is like a like an operating system of this Azure's cloud. So basically, it will control the whole thing like your brain controls all the things. Okay. So what they do basically, so if you see here, Fabric agent is there and role instances are there. Some storage and Fabric agent is there and Fabric controller is there. So what is the functions of various functions of Fabric controller? So just see this structure. So I'm telling you main functionality of this Fabric controller. So it helps to the resource allocation because you need a controller to allocate the resource because resource are demanded by many clients as they are using the public or private cloud services. And some configurations need to deploy over the request, and load balancing will be there, and definitely security task will also be given to that. So how Fabric controller works? Controls all resources including load balancer, computer, switches, whatever resource are required, so that control can be taken by the Fabric controller. Each computer runs a Fabric agent. So what is Fabric agent? It handles load balancing and recovery based on the XML configuration provided by the developer. So simply, if you will go ahead, so it updates and patches for virtual machine running web and worker role. Updates and patches for applications running on Azure, update domains as created. So Fabric controller basically stops machine in one update domain, update the apps and moves on the next domain. So Fabric controller having a very important role, basically, you know that there are many cluster over the Azure data centers. So there actually it is a cluster of servers, and each cluster will have one Fabric controller that manages all the server in that cluster. So it actually communicate between them. So Fabric controller will have a very key role in the case of Microsoft Azure. And if you will see Microsoft Azure queues, so web roles instances are there. So work role instances delete the message after it is done. So this is not a typical queue. Each message can appear multiple times. No first in, first out. Asynchronous services can be provided. So it is like that. Now we will talk about the Azure CDN. So as I told you, the CDN basically it is a content delivery network. So basically this is a content delivery network which with very high bandwidth, because you are transferring very heavy data over that, images, videos, like that. And as I told you, it uses for caching at the S servers with near to that location. So it used for the caching part. So if you want to know that how this CDN works basically, so how CDN will work? So basically a user will request the content. It could be image, video, whatever. And this request basically routed to the content delivery network. And that should be the nearest content delivery network to that user. And if that content is cached there, it will be delivered immediately because we are caching over the content delivery network. So once you will approach the nearest content delivery network, if it is cached there, it will be delivered immediately. But in the other side, that data is not cached, whatever user is required at the CDN, then the server fetches it from the origin server. Then the request will go to the origin server. So that is Azure Blob Storage. Okay. So this is the way CDN actually works. So it provides the capability similar to the traditional content delivery network. It caches blob content closer to the actual server. Useful for delivering multimedia files. because you know what is the problem? Why we are talking about nearest one? Because once you are communicating something through the client and server, you should use some communication medium. And once you are using the communication medium, then you will be bounded over the bandwidth and latency parameter come into the picture. So because of this, so it enables better experience for the end users. Now, the next component which we see, it is called Azure Connect. So Azure Connect basically a legacy service. Uh, in the basically this Connect provide a basically secure connectivity as you have mentioned that between on-premises machines and Azure virtual machines. So it take the issue of legacy services or security. So now the latest version of this service is Azure Virtual Network or VPN gateway. Okay. So what they do allows connecting local resources with Azure, need to run Azure Endpoint Agent on Windows. Connection is done through IP. Okay. So once connected to the Azure, application appears run over the same IP network. So useful for connecting in-house database with the Azure role. So now I am skipping because I have given enough overview of the Microsoft Azure. So now you can get the clear picture and rest components you can cover and you can see how Azure actually functional in terms of cloud computing. So what is the economics of cloud computing? So it provides economies of scale in three areas. Supply side saving, large scale data centers cost much less. Demand side aggregation smooths the variability. Multi-tenancy efficiency, maintenance cost is divided over multiple users. What is the supply side economies of scale? So if you see the number of MIPS, can anyone tell what is the meaning of MIPS here? So that it will be checked all are here or not. Can anyone tell what is Ajit?
Participants can write up in chat box, we will convey them.
Anyone who can tell MIPS? No? Mhm. Just you can tell what is the MIPS here. It is simple. Yeah, good, Snehal. This is million instruction per second. Okay, fine. So now if you will see economies of scale, if you are executing million instructions per second, just see the mainframe in the green color. So if your millions instruction per second is the highest in the case of mainframe, but in the case of client server, it is lower than the mainframe. But in the case of cloud, the interesting thing is that initially, if your million instructions per second is less, then cost per million instruction per second is very high. I think you can understand if you established a large cloud and you are using very less computation, then definitely your overhead will be very high. your cost per million instruction per second will be deduced when you will do deal with the higher number of MIPS. Okay, so I think you got this idea. So cost of power, usually data centers are located in low power cost areas. See, you know that data center needs a lot of power for running over that. So it is a good idea to establish your data center where power cost is less. So like 1 kilowatt hour is 3.6 cents in Idaho versus 1 kilowatt per hour, 18 cents in Hawaii. So infrastructure labor cost is also be considered, and admin can service thousands of computers easily. Buying power, Google pays less than you do for an Intel CPU. So there are many economies, supply side economies, you can say, to scale. So there is some table is given, company name is given, cost is given, size is given. So you can refer that. What is the supply side in economics? So if you see supply side in economics, large scale data center cost much less. So see network, if you talk about the network storage and administration, so this is $95 per megabyte per second per month. Cost in very large data center, it becomes lesser. So you can say that medium size to large data center cost will drastically will decrease for network as service, storage and administration. So this is the data which will be taken, which was taken in the 2006. Okay. So now if we will see demand side economies of scale, so utilization is critical for efficiency, low utilization regions, randomness, people check their Facebook pages at different times, time of, see, it is like when cloud will have a heavy load, heavy demand. So it depends upon according to the time, because many times the request will be hit in the random way. So demand side of economics, you can see CPU utilization rate. Okay. So you can say CPU utilization rate according to the time. So this will be the utilization. It is varying because the hit goes to the cloud is random. So this is because of random variability. Time of day partners for search. So query volume, time of day. So if you will see how much query is passed for searching, then UK, it is highest at 12 to 4 p.m. around, 12 to 4 p.m. But in the Japan, it is highest in the 4 a.m. to 8 a.m. So it depends. So when server or cloud will have the higher demand. So this is the demand side of economics of scale. So aggregating over multiple organization, applications, industries, you may do this. So multi-tenancy economics of scale, fixed application labor amortized over a large number of customers. So variability in demand cloud could be further decreased by multi-tenancy. So overall impact, you can say that number of servers in public cloud and TCO server at average utilizations. You can say that if you will increase the number of server in the public cloud, cost will drastically will decrease. So I am skipping this part because just wait. Okay, just wait. So till now, if you have any question, you can ask. Actually, I have to change the slide. Can you see the PPTs? No.
No, sir. Right now, wait a minute.
No, no. Yes, or shared or not?
No, sir, not shared.
So till now, if you have any question, please you can ask. Any question regarding this, the fundamental structure of cloud, or if you have any query in your mind? I have to add this here. No question till now? I will be happy if you will ask at least some question. Okay, no problem. Uh, Actually, now I am coming over the second part because I am skipping the introduction because the basic details of cloud is completely a big course, but here I am stopping and coming to the next part. So basic idea of cloud we have covered. Actually, what is cloud? And by taking the example of Microsoft Azure, how it works, and how we have seen some data analytics about the economy of it. So now second is data management in the cloud using Hadoop. So just don't bother about any Hadoop or any word. Overall idea is that how we will do the distributed computing over that. So Hadoop is only a framework view two things. Once they will help you to arrange your file in the distributed fashion and also help to provide a computation. So if clouds are there, then you can understand how the task is distributed, how data management will be done in the cloud. So I will tell you one very important thing here. Suppose we have very big data. So big data will be divided into chunks, some small chunks, because you cannot handle solely with the big data. So once it is divided with the small chunks, then these chunks will be stored over the server or nodes. Now the big question is this. Here I will ask one small question. Is it the good idea that data should be distributed over the storage and data should always be sent to the computing machine? Once computation is done, then it should be sent back to the storage. And you know that in that case, in this case, your storage not at your machine. It could be at some remote side or cloud side. So first data will come to the computing machine, and after computation, that data will go back to the storage. So now tell me, is it the good idea to compute the large data or not? Just say yes or no. At least you can do this. You don't want to answer of this question? Where is the pressure? The message is here. No, sir. No, sir. No, sir. No, sir. No, sir. Which is no, sir? Questions wala no, sir, or this is not a good idea to do the computation at one place and transfer the data from computing machine to other side. So what are you saying? Is it good idea or we need to change the method? No. Okay, no problem. So basically it will not work because once you have very large data and you are sending it for computation, you should have latency issue because data will travel through the communication medium, wired or wireless, and it needs huge large time. Even you have a higher bandwidth. And second, you have to incur the cost of data. or internet for transferring those things. So the idea is that you should put the chunk over the server only. So you put the data over the computing machine so that transfer will be reduced. So how things will happen here? So why we use Hadoop for this distributed file system over the cloud? This is huge data sets on large clusters of computer. Very expensive to build reliability into each application. And node reliability is also important. Suppose just assume Google is using 10,000 server, or just assume 1 lakh servers, and the average life of the server is 3 years. So it means 1000 days. So every server fails in once in 1,000 days. So if you will have 1 lakh server, so 100 server can fail every day. So you can understand that the failure rate is very high. So reliability will become very important because nodes can fail at any time. So failure is expected rather than exceptional. So the number of nodes in a cluster is not constant. Need a common infrastructure, efficient, reliable, easy to use. So, like Hadoop Hadoop is a framework which will give you to arrange the file in the way of distributed by dividing into the chunks, and that chunks will be distributed over the server. Not only chunks will be distributed over the server, but duplicacy of the chunk will also be maintained over the different server. And maximum duplicacy is up to 2 or 3. It is sufficient for maintain the reliability. So like Hadoop distributed file system, Google also have a Google file system. Okay. So who uses Hadoop structure? So Amazon, Facebook, Google has own Google file system. New York Times, Yahoo, Cloudera, they use the Hadoop system. So what is the commodity hardware in this case? So see, actually what is happening at the basic end, you will have some your node. Node is a computer which having processing and disk. They are connected with the switches. Okay, but you can connect a limited number of computer in the switches because of the limitation of switch. And further, multiple switches can be connected and make a large cluster. So this aggregation switch will have high data speed, 8 gigabyte, and this rack switch will have low data speed of 1 gigabyte. So this is a typically two-level architecture. So nodes basically are nothing. It is commodity PCs. Do you know what is the meaning of commodity PCs? Anyone? So it is some low cost personal computer. Okay, that type of PCs are there, general purpose. So 30 to 40 nodes can be maintained in a per rack switch. Uplink from the rack is 3-4 gigabyte. Rack's internal has 1 gigabit speed. So we have seen that. So this is making a big cluster by using that. So how Hadoop distributed file system works? So in the case very large distributed file system, 10,000 nodes are there, 100 million files are there. Yahoo is working on a version of the uh, that can scale to large amount of data. Acha, you know what is PB? Can anyone tell what is PB? Can anyone tell what is PB? Can anyone tell PB? Definitely, it is related with the size. So, how many bytes are there in PB? PB 10 to the power 15 bytes. So it assumes commodity hardware. Files are replicated to handle hardware failure. So it is optimized for the batch processing. So I am coming to tell you this structure. Okay, so it will give you the better idea. So if you will see this structure, there are some name node. In the HDFS system, there is some name node. So basically, name node is a node will so basically name node is a node which will contain all the metadata, because what was the purpose of HDFS? They distributed the file over the different nodes. So who will take the record, where it will be stored, how much duplicacy of the chunks are maintained, and where are the duplicate chunks resides. So all this information will be there in a node which is called name node. Okay. So this is a client, this is the data nodes. So this is suppose rack 1. This is rack 2. So what they are doing, so you can see every rack node will have a certain chunks over that. So this green color are the chunks. So you can assume that suppose this is ABC, this is BC, this is AB. So some of the chunks are repeating over the multiple nodes. Okay. So that is the idea which is used here. So some replications are available because see here all the chunks are mentioned in the color green, but actually they may have some duplicacy, like a big process P divided into 4 chunks, P1, P2, P3, P4. So I will distribute P1, P2, P1, P2 here, P, P, P3, P4 here, P1, P2 here, P3, P4 here. So replication will also be there. So all thing will be taken care by the name node. Name node actually metadata. So what is the functions of a main name node? So it manages file system namespace. So maps a file name to a set of blocks, maps to block to the data nodes where it resides, cluster configuration management. So name node is a metadata, so we talked about, and some nodes are data node which actually contain the chunks. The large file which is divided into the chunks, they will take care over that, and some replicacy of data will also be there. So I directly come to the term. Okay, so yes. So block placement is there. So what is the strategy? One replica on local mode, second replica on a remote rack, replica on the same remote rack. So I told you the replication of any chunk can be go maximum up to 3, 2 to 3. So one replica node should be on the local node. Where is it? Second replica should be on remote rack. You know that because change the geographical region. Third replica on the same remote rack. So additionally, replicas are random. There is one way you place the replicas randomly and wait. So we always know that client always read the data from the nearest replicas. So we already talked about the caching of that data so that content delivery network will take care about that. So data node send heartbeat to the name node once every 3 seconds. Name node uses heartbeat to detect data node failure. So it is called heartbeat. So every time they check that data node is working or it is failed. So there is a replication engine. So name node detects data node failure, chooses new data nodes for new replicas, balances the disk uses because all disks should be covered so that we can get the maximum efficiency in the terms of computation, balances communication traffic to the data nodes because some of the traffic is still communicating. So that should be balanced. In that way, replication can be used. So data correctness can be checked by various checksum techniques by CRC32. File access method will be used. You know that file creation here. So name node failure. So what will be the happen if your name node which contain the metadata will fail? So a single point of failure, transaction log is stored in multiple directories, a directory on the local file system, a directory on a remote file system. So it may depends remote, whether it is remote or local file. So client retrieve a list of data nodes on which to place replicas of a block. Client writes block on the first data node. The first data node forwards the data to the next node in the pipeline. So that will be the procedure which they follow. When all replicas are written, the client moves on the right to the next block in the file. So there is a rebalancer also. So what is the goal of rebalancer? Percent is full on data node should be similar. So it balances that the percentage of disk fillingness on the data node should be uniform. Usually run when new data nodes are added. So cluster is online when rebalancer is active. Rebalancer is total to avoid network congestion. So if we will put all the data on the same side, that side network congestion becoming start. So there is secondary name node also. I'm not going into that detail. So now I will tell you. So actually now the thing is this, currently we were talking about HDFS, Hadoop Distributed File System. So what is MapReduce? So MapReduce basically a distributing processing model. See, you distribute till now we have seen the distributed file over the you know that na I get a meeting weekend after I should not you like this I stop the meeting and coming out. You can wait if I'm talking to someone. No, it is very irritating if somebody is standing outside. So MapReduce basically a technique by which we can do the computation. Uh, I have class.
Okay. Once, like yes, so we have talked to Vaidyanathan sir. He told like he didn't receive any information, but just to check with account session,
See, please take the 5 minutes break. Okay? So we will continue after 5 minutes break.
That's it.
Hello, sorry, actually some work came. This is the problem in online lectures. Okay. So we were discussing about this Hadoop file system. So we were talking about MapReduce. So MapReduce is a process by which we are able to distribute the file and compute it. So how the large file will be distributed, because over the cloud structure it is required, because you have a large clusters. So how you distribute the files and do the computation. So MapReduce is a programming model. I think you can hear me, no? Okay. I think you can hear me, no?
Yes, sir.
Okay. So MapReduce is a programming model. So actually, this is a programming framework. See, parallel computing is not a easy task, and how to distribute the file over the chunks. So this is a complex problem. So these things can be handled through the MapReduce method. So what is MapReduce? So just see. So just take one example. You have seen how election commission perform the voting and its counting. So just assume that election commissioner is a computation. Okay, they do the computation, and once you use so election commissioner is a computing device, and at India at many places voting is happening. So at voting centers, there are many voting centers across the India. Okay. So what is happening? This voting centers can be considered as distributed file over the India. So how after the voting counting will be done, that all the votes from the distributed center from the India should go to the election commission office, and there should be counted. So that idea is called कि your computing machine is staying at one place, distributed files are distributed at other place, files are coming to the computing device, and then computation will be done. So in this case, what will happen once the votes will be travel from the distributed area of the city country to the election commission office, then lot of traveling cost will be there. So what is the idea? From the election commission office, they will send some of the people to the various places for count the voting. Once counting will be done, then this counted information will travel to the election office. So the person, those are going to the voting center for counting the votes at the different places in India. That is called कि we are putting computing over the data. So data is not travel to the computing. Computing is put over the data. So how this thing will happen and how aggregated result will be collected, that whole thing will be taken care by the MapReduce. So how MapReduce data flow will work? So MapReduce basically two functions. One is map function, then again is reduce. So what is the mapping process basically? So in a mapping process, basically you distribute the you actually generate the key value pair from the large document. Key value pair means just the keyword and its value. Suppose you count, then from the document you will take the word and its count. So key value pair will be taken from the map process, map function from every node. So this orange color is nothing. It is the key value pairs that will be fetched out from the document. And what will happen, that key value pair will be aggregated. So aggregation will be done by the reduce function. But before applying the reduce function, we will actually many keywords are lying at same keywords are lying on multiple nodes. So how we do the aggregate the things. So before that, we will apply a group by function. So group by function, what group by function will do? It will combine or group the entities, those will having same keys. And what reduce function will do, once grouping will be done with the same keys, their value should be combined and you can generate the count. So there are two processes mainly, map and reduce. In between there is a group by function is also there. So preloaded local input data is there. This is input. This could be a very large document. After applying the map process, you will get an intermediate data from the mappers. It is a key value pair. And value exchange by shuffle process. Shuffling means group by. If you remember the group by command in the database, that will be applied at the shuffle process. And lastly, it is the reducing process where all aggregation will be done and final counting of votes. Like votes are counted at multiple places, collected here and make the total. So map reduce features, fine grained map reduce task, balancing faster recovery from the failed task. So I'm not going to the details. So word count example is there. So I already told you. So this is the word count example. So suppose this is the large document, deer, bear, river, car, river, deer, car, bear. So how it is splitted? So we will split the first row, second row. By any way you can split this thing. So what mapping function will do? Mapping function, actually this splitting is called divided into the chunks. So 3 chunks are divided with this large data set. So these are the 3 chunks. So mapping means key value pair. So key is deer, value is 1, bear is 1, river 1, like this, car 1, river 1. So every key will be written separately, not combined, because computer cannot understand at single level that it should be combined also. First we will separate it out. Deer, car, bear. So deer 1, car 1, bear 1. Now shuffling process is group by process. So what will happen? Bear two at this two bear will be grouped one place, bear 1, bear 1. And again car will be grouped from this 3 place. So grouping will be done according to the keyword. And what reducing function will aggregate the values as per the keyword. So bear, 2, car, 3, deer, 2, river, 2, and final result you will consolidate here. So this is the overall data flow for a word count process by using the map reduce. Okay. So I hope this process is clear to you. In this way, map reduce will happen. So this is the example, and through command you can do this. So now we will talk about something about the cloud security overview. So first we will talk about Amazon security overview. So AWS is compliant with various security certifications. So what are the various security certifications are there? See, what is the reason of security? Because somebody is using your data. So they are accessing your data. So once they have data, so because of the public cloud, resources are shared, so data leakage will be there. So they have to use certain security policies. So what are the various security certifications they need to take care? First is FISMA, which is Federal Information Security Management Act. That is low level certification. So internal information communication and employee lifecycle management to increase the security. So what about the physical security of the Amazon Web Services? So in this case, various data centers are protected by many security features and safeguards. So two-factor authentication, security force, etc. So fire detection and suppression, power security, climate and temperature safeguards. So various level of physical security be required. So if we will see the AWS configuration and continuity management. So in this diagram, if you will see, it is divided into the various region, and various regions is divided into various zones, and various zones will have various servers. Okay. So in this diagram, you can see that you have US East region, EU region, US West region, APEC region, Singapore, APEC region, Tokyo. So there are 3 zones here, 2 zones here, 2 zones. So, and under the zone, there are multiple servers. So this is the configuration which is managed. So changes are reviewed, tested, and approved before rolled out. So different availability zones, 2 separate faults. So actually some data replication so that reliability of data should be there. Different regions could be selected for regularity compliance or increasing reliability. 24/7 incident response team is there to maintain all the things. Because once you divide something under this hierarchy, then control may be easy. Backups for stored data is there. Physical devices erased using DOT or NIST media sanitization technique. So what is AWS identity and access management? So for each AWS account, you can create multiple users with different credentials. So for each user, you can give different rights. So we know that every user cannot have the same rights. So more detail and on this when we cover identity management and cloud. So multi-factor authentication based on the hardware tokens will be provided. Key and certificate rotation for increased security. So what is AWS network security features? So increased reliability against DDoS, SSL-based access to almost all resources to prevent man-in-the-middle attacks. All EC2 instances, needs to use their actual IPs and MAC addresses. So EC2, you know that it is a elastic compute cloud, Amazon EC2. Okay, Amazon Elastic Compute Cloud. So basically, these are resizable virtual servers. So packet sniffing by other tenants are prevented by hypervisor. You can create your virtual private cloud and a distinct isolated network with cloud. So how EC2 security will be provided? So once you talk about the EC2 security, Elastic Compute Cloud. So basically, AWS EC2 security ensures you that your virtual servers are protected from the unauthorized access, any data breaches, or any attack which may happen from the outside. So it can be maintained at various level, or how host operating systems are protected. Basically, two-factor authentication and auditing is there. And guest operating system must be controlled by users. Firewalls are there. So we can talk about many other contents of there. So if you see major key components of the EC2 firewall, I think all of you are aware with the firewall they use for the security purpose. So basically, if we will talk about the EC2 firewall, so so there are different tiers are there: web tier, application tier, database tier, EBS volume. So AWS employs a private network with SSH support for secure access between tiers, and it's configurable to limit access between the tiers. So basically, the EC2 firewall is implemented through various security groups. Okay. So if you see the EC2 firewall, basically just equivalent to a security group. So virtual firewalls are there for all EC2 instances. So you can see that port 80 and 443 only open to the internet. engineering staff have SSH access to the app tier, which acts as a bastion. Authorized third parties can be granted SSH access to select AWS resources such as the database tier. All other internet ports blocked by default. So various policies you can apply over that firewall. So what are the EC2 firewall features? So firewall is not controlled through guest operating system. Guest operating system level firewalls could be added for additional security. So what is hypervisor based isolation? So hypervisor are used to limit access to resources to maintain isolation between the instances. So because of this, we use the hypervisor. So you can see that there are multiple customers. If you will hypervisor over the virtual interfaces, then customer one security groups, customer two security groups, it can be divided into the various security groups over the firewall. So some SSL based secure APIs are there, authentication based on HMAC here. So HMAC, if you know that it is the hash based management authentication code or public key crypto. Different security groups are there, possible access logging is there, data can be encrypted by the customer. So now you can see this Microsoft Azure overview. So in this, you can see in the illustration of window Azure component and relationship. So this is the customer. This is Windows Live ID. And they will get through its subscription, service managed portal APIs there. So these are the hosted services. Various hosted services are there, tenant and what are the role. Different node and node fabric controller is there. Here load balancer is also present so that end user can interact from them. So it can be divided into two parts, hosted services and storage account. So both can be accessed by the customers. And whole thing will go through the HTTP hypertext protocol. So we already talked about the structure of the Azure. So each role instances in a new virtual machine. So virtual machines run on Microsoft Azure hypervisor. So FAs manage guest agent with guest OSs on customer virtual machines. The collection of hypervisor virtual machines, FA and customer VMs comprises compute node. Okay. So how Microsoft Azure authentication will be done? So as SMA PI, I think you are aware with the SMA PI and REST protocol. So there are system management API and you also know about the REST protocol. REST protocol runs over the SSL using self-signed certificates. So certificates and keys stored separately by the user and it encrypts the key secret. So basically Fabric controller keeps separate master key and authentication keys to authenticate with hardware devices. So if you see the summary of various Azure authentication mechanisms for customer subscription, mechanism is Windows Live ID. For developers and operators, Windows Azure Portal API, Live ID for self-signed certificate. For role instances, storage is object, external applications, stores are object, storage account key should be there. And for the external applications, various applications so how we do access control in Azure storage? So user can create multiple accounts. Each account has a storage key. So given a storage key, you can access all the data related to the storage key. No fine-grained access control. Data can be made publicly readable. So this is the access control in the Azure storage are there. User can sign query templates using storage account key. Container level access policies are also possible. Two keys could be valid at any given time to allow key updates. So this is Azure isolation. So I have to come this Azure packet filtering. So how Azure packet filtering will be done? So routes, operating system, and hypervisor filter packets to prevent spoofed and unauthorized traffic. So basically, the method of packet filtering in the Azure is basically leads to the controlling network traffic, है ना? Because packets are moving over that to and from where this network traffic is going on to and from Azure resources based on the various source IP, destination IP, and various protocols. So actually, how this packet filtering will work? So each packet entering and leaving the network, you know that. So we should define some rules so that we should allow the packet or deny the packet. So customer access to virtual machine is limited. As example, no remote terminal connections are there. Connection between different application is considered internet connections. So the majorly this Azure packet filtering can be lead by two components. One is network security groups, one is Azure firewall. So they will be helpful for that. So cryptographic tools for data encryptions are used. Data deletion for disposed hardware. Integrity checks will be used for data. Backups to increase the availability of the data. Monitoring agents gather data from FCs and root OS to create the audit logs. Personal policies, physical security similar to the Amazon will be used. So what are the main security problem of the clouds? So VM level attacks. So they exploit potential vulnerabilities in the hypervisor. Cloud provider vulnerabilities are there. So that is cross-site scripting vulnerability in Salesforce.com. Phishing is there. So you can see the cross-site scripting vulnerability in the Salesforce.com site. So integrating cloud authentication with company authentication mechanism, availability, single point of failure, assurance of computational integrity by the cloud provider. So will cloud provider fight against the subpoena? Do you trust Azure logs to show gross negligence on Microsoft part? Contractual obligations. If you can hack one place of espionage Gmail, then then sorry, Gmail could be a good starting point. Data lock-in. So, you know, espionage is the basically a way by which spying or obtaining secret information. So how hack one place for espionage Gmail could be a good starting point, data lock-in. So what is new in cloud computing security? Too big to fail. Okay, it is too big to fail. What if Amazon hardware is confiscated? What if Amazon fails? So hiding activity patterns, using cloud for crime, secure cloud auditing, mutual auditability is there. So this is the major, this is the very new thing in the cloud computing security, and you can start working over that. So just take one example. What is the secure cloud auditing basically? So in the secure cloud auditing, basically it is the method for do the inspection, evaluation, and verifying the security and privacy compliances over the data. And why it will become important nowadays? Because most of the cloud services are managed by third parties. So user needs assurance that data is confidential, intact, and available. So this is very important thing to handle nowadays. So if you will go more, then you can see that data integrity should be there, access monitoring should be there. So there are various things which you should take care about it. So now if you will talk about this cloud for crime. So what is cloud for crime? So it is basically there are various illegal activities that exploit cloud computing resources. Data theft will be there, account hijacking may be there, denial of service, DOS attack is there, insider threat, malware can be injected. So there are many possible problems because of this, which is called cloud for crime. So it's all about the today's lecture. So if you have any query or questions, so you can ask, and thanks for listening the lecture patiently. So any question or anything which you want to share here?
Participants, if you are having question, you can put up in chat box. So, sir, I think there are no questions. So, sir, thank you
ठीक है,
for
ठीक. Okay, okay.
joining us for a pretty good, like, we truly enjoyed your grateful insights on cloud security.
Okay, thank you.
To the participants, the next session will start at 4 p.m.